All right, it's recording. Here we go. Exercise 4C. We're going to revise through area of basic shapes. Okay, so what is considered a basic shape? Rectangles, squares, triangles, and eventually we're going to go back to 4B, circles. You're going to learn circles. In the meantime, what I want you to copy down is, as we're doing a discussion to revise, our memory on the formulas for the area of these basic shapes. Let's go. I want you to write over here, and I do want you to draw the shapes into your exercise book with those notations. See those dashes? I want you to have those dashes. Very good. Very good. That is what it means. All right. Let's go with the first one. Shh. Excuse me. Don't forget my 3 rules. Don't speak while I'm speaking. It's disrespectful. And no throwing. Thank you. All right, here we go. Area of a square. What is the formula for the area of a square again? Can I please have... All right, Michael.
Is that length times width?
Length times width. Very good. Length times width is the area for a square, but we can also write it another way. Sometimes they write it in a different way. What's another way that you might have seen in the past? Anyone know? Hands up if you know. Length times... Not by 4, that's perimeter.
You can plus all the sides.
No, that's perimeter again.
Times 2.
Not times 2, that's doubling it. So it means you just double the length. It's going back with what Michael was saying. He said length times width. Now, if this is the length...
Oh, L times L.
L times L. Now, why can you also write it as L? And how do you know it's all the same size? They have the lines. Okay, so when I don't tell you that it's a square... So they don't tell you it's a square, but they tell you by the symbols. You need to learn how to recognize those symbols as well. Another way to know it is a square, not only just the sides are the same, what else is also special about a square? Right angles, very good. Now, I'm going to extend your understanding. You might have seen another shape. What's the shape where all sides are the same, but it's not a right angled again? What's this one?
A parallelogram.
Not a diamond.
Rhombus.
It could. Yeah, oh, it is a sort of parallelogram, but specifically, this particular shape has all sides the same. But it's not a square because it's not all right-angled triangle. There's no right angles there. It is a rhombus. Very good. Someone also said rhombus over here before. Ryder said rhombus. Anyone know how to spell a rhombus though?
R-H-O-M-B-S.
Very good. Rhombus. We'll be learning that later on, but at the moment, these are called basic shapes. Anyone remember back in indices, what do you do, or algebra? L times L. What's another way of writing L times L?
L2. L with a little 2.
Very good. L squared. Very good. Copy that down for me, please. So the symbols, I want you to make sure you've got the dashes to mean that they are equal lengths. And then make sure to draw the square boxes inside each corner to mean 90 degrees. So I'm going to write here 90 degrees. That's what it means. And here means equal lengths. All right. Let's do the same for the area of a rectangle. What is the area of a rectangle? What's the formula can I please have? Let's go with Logan. Length times width. Very good. I'm going to do L times W. And in this case, that is your typical area formula, meaning that if you know the length, you then multiply it to the width, which is a perpendicular dimension to your original length. Multiplying those two together will give you the area of the shape, in this case, rectangle. Okay. Now, in year 11 and 12, I often remind students there is a difference between length and width. What is the difference between the length and the width?
Length
is longer.
Say it again.
Length is longer.
That's the key thing. Okay, so in year 11 and 12, they will say things like L is greater than W, and then move forward. And sometimes they don't tell you, and you're meant to write it down as part of your answers. And that's where they're losing their marks in the senior levels. Okay? But you have to remember length, specifically, when you say length, it is the longer side compared to the other dimension. So the width is always the shorter one, and length is always the longer one. Okay, so don't write it the other way around. Don't write W and don't write L. It is length is the longer side, and width is the shorter side. Okay? All right, here we go. So we've got length times width gives the area of a rectangle. Let's go on to our next basic shape. This. What shape is this?
Rhombus.
Now, rhombus has to have all sides the same, and we can see that's one dash, but that's two dashes. So not all the sides are the same. So it's not a rhombus, but it is very good. Anyone know how to spell that, though?
P-A-R-A-L-L-E.
Very good. Parallel, so spell parallel first, and then ogram. Okay, parallelogram. All right. Anyone know the formula to find the area of a parallelogram?
Is it still L times width?
Well, in this case, we don't have L and we don't have the width.
Base times.
It is base times height in this case. Now, notice the thing about all three formulas. Have you noticed that it's always one, it's a two-dimensional shape, so it's flat. But two, that the two dimensions that you multiply is always 90 degrees. So notice here, length is 90 degrees with length, 90 times 90. Notice over here, it's length, 90 degrees with width. That's length times width. And notice, even in this formula here, it's not, and this is where the common mistake is, most students do this length times a diagonal. Okay, it's not. It's always multiplied to the 90 degree length. Okay, so that's why, again, this is the length that you have, which they call the base, and then multiplied to a vertical height, which is 90 degrees. Okay, so even think about a triangle. Triangle's the same thing. It's base times the height, and it's 90 degrees as well, and then you're halving it. Yeah? We're going to look at that later, but at the moment, I want you to remind yourself that it's usually we don't multiply the slants, we multiply it to the 90 degree intersection, okay, in a two-dimensional shape. All right, so here, I want you to write your formula down. It is, the area is base times the height. Okay, so I'm going to highlight it for you to see. This is your base, and this is your height. That's the height. And it is currently 90 degrees with each other. Okay, you'll find that later on doing trapeziums is also 90 degrees with each other. That's one of the hints when you're doing your times tables or multiplying them to make sure you're not making a mistake there. Okay? I do want you to make sure to put in the symbols. As you're drawing the shapes, draw the symbols. Out of curiosity, what do these arrows mean? Notice these arrows here. It means parallel. Okay? Now, how many pairs of parallel lines are there? Two. Okay, this is going to be important to understand because when you do trapezium, which I'm going to draw on the side over here, a trapezium only has one pair. So here I go. I'm going to draw one pair of parallel lines, and as long as you connect it into a four-sided shape, that is going to be considered a trapezium. So if I did like this, that's one end, and then I connect it to this side, that's now a trapezium. You can also have, again, one pair of parallel lines, and then I could do two slants, but as long as they connect, that's four-sided shape. That's a four-sided shape up there as well. Those two are called trapeziums. And how do you know? It's only one pair of parallel lines. How do you know it's a pair of parallel? There's only one set of arrows. Okay? So that's why you need to know how to read the notations, even though they don't tell you what shape it is. Reading the notation should allow you to identify what shape it is. Okay? So we have a parallelogram. Area times base. Very good. And then going on to our last shape, or second last shape, sorry. Our second last shape, triangles.
Is it H times V divided 2?
Very good. This is the area for a triangle. Anyone know why?
Because triangles can always be put into, like they're always, half of a square or a rectangle.
Very good.
And so, that's why you can just divide that.
Very good. That's exactly what it is. It's essentially saying that if I can multiply in a triangle, this triangle here, if we call this the height, this the base. You see, if you did base times height, all you're really doing is you're finding the area of a rectangle. It's like length times width. But you want a triangle, which is really only just half of that. That's why they're removing this half and you get a triangle. But essentially, you're just doing length times width. So another way of looking at it is length times width divided by 2 will give you a triangle. Okay? But again, one of the things that I always mention to students is that notice the two dimensions that you're multiplying are 90 degrees with each other again. They're all 90 degrees with each other. Okay? So that's one of the things you should be looking for when you're multiplying. Do I multiply the slants? No. It's always looking for that 90-degree dimension because that's a 2D shape that you're working with. Okay? And then the last one, what shape is this called? Even though they should have had arrows there, which I'll put the arrows in. What shape is this called?
A stuffed up rectangle.
Stuffed up rectangle. Very interesting.
A rectangle plus a triangle.
Yeah. Rectangle.
That's actually, yeah, it is true. It's a rectangle plus a triangle. But I'm just going to jump back to the question that Mike had.
What happens if it's not a right angle with the triangle?
Which one? This one?
Yeah.
Or that one?
The top one, that one, the higher up one. What happens if with the height and the base they're not a right angle? What happens if they're like?
Oh, if it's like 60 degrees. So if you had, well, they usually have to give you the 90 degrees one. If they don't give it to you, you'd have to use a year 10 mathematics skill to figure out the area of it. But at the moment, you're not learning that. Yeah, but there is a way to do it. All right. This shape here, I want you to copy this down. This is, again, notice I put in the arrows for you. They have one pair of parallel lines. When you have one pair, what's the name for this shape again? Trapezium. Very good. So this is a triangle up here. I want you to write down the area of a trapezium formula. So I'm giving it to you in advance because you can do this in two ways. You can do it the rectangle plus the area of a triangle, but it takes longer to do. So I'm going to give you the formula for a trapezium. So they've already done the hard work for you. They've summarized, they've done a rectangle, they've added a triangle, and have summarized it into one nice formula, which is half times A plus B times height. This is the formula. Now, how does it work? A is either length. So the two parallel lines, remember how I said one pair of parallel lines? Those two parallel lines, either one can be A or B, doesn't matter. But one of them is A and B. You add the two lengths together. Okay, so B is the length from, I'm just going to do it over here so you can see better. B is this length and A is this length. When you add those two together, multiply it by half or divide it by 2, and then don't forget to multiply it by the height, which is, this is the height.
What happens if they don't give you the one?
They will have to for it to work. Otherwise, you can't figure it out. Yeah. So, notice again, where is my 90 degrees? Remember what you're multiplying to, A plus B times the height. Notice the height is also 90 degrees again. Okay, it's always 90 degrees with the two dimensions you're working with. In this particular case, there's only one additional length here, A plus the B times the perpendicular height. That will give you the area of trapezium after you halve it. Okay, so please copy that down. I've just added one extra formula that is a bit different to what you might have seen in the past. So make sure to copy that down. Make sure to copy it down. Make sure to copy it down. Make sure to copy it down. Trapezium formula. Okay? Thank you.
It doesn't matter which one's A and B.
Very good. A lot of students get confused which one's A or B. It doesn't matter. As long as you have the two parallel lines, either one is A or B, doesn't matter. You're just adding the two lengths together. Okay. Make sure to have these in your notes. AJ.
If the A plus B is in the bracket, that means you do it first, right?
Very good. So you add the two sides first, then you can multiply to height and then multiply to half if you want, or you can halve it first and then times to the height. Doesn't matter about the order. All right. Now, one last set of notes. And then we'll do some examples together. Here we go. This is what I want you to copy into your exercise book. You are going to refer to this quite a bit. And I'm going to write up here just to remind you as well, km to meters, to kilometers, to meters, to centimeters, to millimeters. There's a common misconception or common error, and I want you to copy down this flowchart. Here we go. Let's remember in perimeter, or just lengths, not area units, but just length units. How many millimeters are there to make 1 centimeter? 10. Okay, so 10 of these millimeters make only 1 centimeter, right? So, going from millimeters to centimeters, or centimeters to millimeters, let's think about it. If I had 1 centimeter, listening, don't talk while I'm speaking. If you had 1 centimeter, so the number is 1, what do I have to do to the 1 to get 10?
Times by 10.
Very good. So commonly, when I ask students a question without them thinking about this first, I say, how do you change centimeters to millimeters? They're like, divide 10. And it's not divide, it's times 10. It feels counterintuitive, but when you look at the numbers, it makes more sense. See, 1 centimeter is equivalent to 10 of these millimeters. So when you're moving from centimeters to millimeters, it is times by 10. But then when you go millimeters to centimeters, you are now, what are you doing? How do you go from 10 to 1? Dividing by 10. Now using the same concept or understanding, 1 meter is equivalent to how many centimeters again? 100. So if you follow the pattern, how do you go from meters to centimeters? So from 1 to get to 100, you would have to? Times it by 100. Very good. So we got times 100. Then kilometers to meters is times what? 1,000. So I want you to copy this down, the flow chart. I'm going to get you to copy this flow chart down. Here we go. This is now divide 100, and this is now divide 1,000. See what I'm doing? I want to see this chart in your exercise book because we often assess your conversion skills. It's part of your Australian Bell system that you need to know how to do conversions. It's interesting that, you know, most people forget how to convert. Even my cousin who was an engineer, graduated engineer course, he forgot how to convert cubic, so volume into, cubic centimeters to cubic meters. And it's because we don't understand the concept or we don't practice it often enough. That's why I want you to copy the chart down. It's part of construction and conversion. Yep.
Does that mean that it's 1 million millimeters to 1 kilometer?
Yes. Yes. Very good. Very good. That's correct.
Times very small.
Sorry?
This times very fast.
Yeah,
Yes, and that's where it's counterintuitive. That's why I was saying that a lot of students mix it up. If I ask them directly, they'll say it the other way around. But if you look at it mathematically, you can see why. That's why I want you to copy down the chart, because I know it's a common mistake. Okay? Now, that's called length units. I'm going to write up here. This is called length conversions. What you see below that is in your textbook, we're currently working with area. So these are called area units or area conversions, but there's one small difference between them. Notice this is km, m, cm, and millimeters, but notice these are km squared kilometers, squared meters, squared centimeters, and squared millimeters. Notice the language I'm using as well. A lot of students read it like this: millimeters squared, centimeters squared, meters squared. No. In the actual language, when you read it, if you buy a house, they normally talk about squared meters. This is what they're referring to. Okay, so we read it as squared meters, squared kilometers, squared centimeters, and squared millimeters, not the other way around. Okay, so if you read it next time, if you see it on realestate.com, that's what they're referring to when they say squares or squared meters or squared centimeters. That's what they're referring to. Now, in your chart, everything is the same. You're still doing times 10, times 100, times 1,000, divide 1,000, divide 100, and divide 10. But there is one difference. And the difference is if these are area units, then you are not just timesing by 1,000, but it's 1,000 squared, 100 squared, 10 squared, 10, and then 100 squared, and 1,000 squared there. That's the difference.
So it's timesing it by.
So the first one.
1,000 and then timesing it again by 1.
Very good. So that means this is now 100. That's 100 times 100, which is 10,000.
Yeah, doing like instead of timesing it by 10, timesing it by 100.
Very good. So that's the difference. And that's for area units. So when you do volume, the flowchart doesn't change besides the fact that it's cubed. So area is squared, length doesn't change. So length is as it is, area units squared, and then cubics would be cubed. Okay, so right now that's what I want you to copy down, just the flowchart, so that when you do answer the questions later, you can use the flowchart to work through the questions for conversion. Okay, and you've got the formulas for your shapes to find the areas, and that's what today's session is about. Okay, so the two skills I wanted you to take out is, can you find the areas of the shapes, basic shapes? Remember the formulas. And number 2, can you do unit conversions? Okay, so area unit conversions. That's what I'm looking for. Okay, so 2 skills. Copy down those notes, and here we go. For those who are still copying, you can still look onto OneNote, or we're going to do this question together right here. So here we go. They want you to convert, in this example 6, they want you to convert these area measurements to units shown in brackets. They want you to convert 0.248 squared meters, not meters squared, squared meters into squared centimeters. So what they're trying to say is they want you to convert 0.248 squared meters is equivalent to what? Squared centimeters. Yes, Michael?
Is it 24 centimeters? Oh, but it's squared. So would that mean it's...
Well, you're doing it well, yes. Yes, you're almost there.
2,480 centimeters squared?
You're amazing. That's exactly it. So for those who are wondering how you are doing this, so looking at the questions here, listening, shh, team, focusing. This question here, Mike was able to do this without using a calculator. How did he do it? Let's first think about what he did. He looked at it and said, okay, that's squared meters, and we want to convert it to squared centimeters. Looking at our flow chart, squared meters to squared centimeters, it says here times by 100 squared. Okay, so it means that you are going to be moving it 100 and then 100 again. So if we write it down, 0.248 times 100, and then we're going to times 100 again, because it's 100 squared, boys, thank you, times by 100 times by 100. How do you do this again? Remember at the start of the year, we talked about how to multiply it by 100. What's the short way of doing this again? So 0.248 to the right or to the left?
Right.
To the right, because it's getting larger. When you're timesing, it's getting larger, so the value should be getting bigger. When you're dividing, it should be getting smaller. So we're moving to the right by 2 spots. But remember, it's timesing by another 100, which is why we move another 2 spots, 1 and 2. And that's why what Mike was doing there was he realized that it wasn't 24.8, but then it has a space here that makes it 2,480. That's where he got 2,480 squared centimeters without using a calculator. Okay? Thank you. All right, so please copy those notes down. That's the conversion technique. Today's session, you're going to use the flowchart and the formulas that I've given to you to answer the questions. Okay, so I'm going to give you a bit of time to copy that before I move to the questions, and then you know which exercise. This is exercise 4C, basic area shapes. I won't see you tomorrow because it's student-led conference tomorrow, so I won't see you until next week. Okay, so I do expect this is the work that you should be doing this session, but by next session, we're moving on. Okay, so I'm expecting that we're going to be moving on. Yeah, we are doing this. All right, here we go. This is your question to do. Remember, this is 1 star, so I'm going to write here 1 star, 2 stars, 3 stars. There you go. You got your questions over here. You can choose which set you want to do. You can choose to work in between the sets. That's what you want to be able to start off with 2 stars. But if 2 stars is too difficult, move back to 1 star. But that's it for today's session. Thank you. Here we go.
Are we leaving?
This is your time to do work.